Okay, so this is a discontinuous integrand. Okay, what we mean here is, this function here and this function here. You have this vertical asymptote at x is 0. Okay, so how do we handle these in general? Well, I'll give you a definition down here. Okay, pause and copy. Pause and copy. So let's draw some pictures to illustrate. So here you have A and B, and the problem in part 1 is at B. So you have this usually a vertical asymptote, and you have something like this going on. So what you do is you put a T here and you let it move this way. Okay, for 2, that's the one we just did. A here, B here. The problem is at A. Typically a vertical asymptote. You stick a T there and let it move towards A from the right. In part 3, you have some issue happening in the middle. Okay, so you have A, and you got B, and you got C in the middle. So maybe you have an asymptote on both sides, like this. So what we're going to do is we're going to break it. So we break our original into 2 smaller pieces. And we'll say the original is convergent if both of these are convergent. And otherwise, the original, this guy, is divergent. Okay, pause and copy that if you haven't done so already. And we'll move on to an example, something more complicated. Okay, sometimes the discontinuity is not so obvious. 0 pi over 2 cos theta, theta, all over square root sine theta. Okay, this is a tricky one, because where is the discontinuity? Well, it happens when the denominator is 0. Is 0 when sine theta equals 0? So where does that happen? That happens, does it happen at 0 or does it happen at pi over 2? It happens at 0. So I've found this 0 here. That's what tells me, because I got the 0 here, that's the one, that is the one that gets replaced by t. And am I going 0 plus or 0 minus? Well, draw myself a little picture down here. I'm sticking the t here, right, inside my interval. and it's moving that way. So it's approaching 0 from the right. So I must put a plus here. Okay, this is worth half a mark, getting that plus there. Okay, so I'll repeat. You take your interval from 0 to pi over 2. T goes in the middle, and then it's moving towards my problem spot. So I can see by looking here that T is approaching 0 from the right, so I put a plus right there. And again, worth half a mark. Okay, now I go ahead and do the integral. I would do u is equal to sine theta. That's substitution. And what would I get? I would get root sine theta. With what, a 2 in front, I think? 2 sine theta. But yeah, looks good. T over 2. So that's 2 root sine of pi over 2 is 1. Minus 2 sine t minus, which is 2 minus 2, 0, which is 2. Next, another example. Let's do rather an exercise here. Why don't we switch it up? 0 to pi over 2 from of, we'll switch the cos and the sine around. What does this change? Well, quite a bit. I'll get you started here. This is 0 when theta equals, in fact, it's the pi over 2. So what does that tell me? It tells me that to start here, I'm going limit t goes to pi over 2. And it's actually the 0 that gets left alone. And the pi over 2 that gets replaced. Now, one more thing. I got to make sure. Is this pi over 2 plus or pi over 2 minus? Well, again, 0, pi over 2, stick your t in the middle, and it's going this way. So it's approaching, t is approaching pi over 2 from the left, so I put a minus here. Okay, I'll let you continue this one. And hopefully you'll get 2 again. How about this one? What is the issue here? Okay, so the discontinuity here, ln x has a vertical asymptote at x is 0. Okay, so that is telling me that I should be going limit t goes to 0 from the right in this case. And then to find the indefinite integral of x ln x, this is going to require a by parts. So I get du is equal to, so just doing this quickly, v is x squared over 2. So I get half x squared ln x minus integral of x over 2 dx half x squared ln x minus x squared over 4 plus constant. Let me just double check that's correct. U is that, dv is x ln x, blah, 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 blah. Derivative. Okay, looks okay to me. T to 1. Now here we are looking at this guy. And what do we get? When we plug in 1, we get 0 minus a quarter. And when we plug in t, I lost my limit. Sorry. When we plug in t, we get half t squared ln t minus t squared over 4. Now t is going to 0. So what does that mean? It means you get the minus a quarter from here. You get minus, something strange is happening here. So let's just leave that under the limit. Nothing strange is happening here. It's just going to be 0 minus 0 over 4, whatever. So we get minus a quarter minus a half limit t squared ln t. So careful, careful, careful. What is strange here? Well, what you have is that the t squared is going to 0, but then the ln t is going to minus infinity. So as we talked about in Appendix B2, we need our friend L'Hôpital. I need to go to the L'Hôpital. So how do I do that? Well, remember, you want to force this into a fraction. So you pull that t squared down to make it t to the minus 2. And then you do your L'Hôpital. Minus a quarter, oh my gosh, minus a half limit 1 over t. And what happens here? minus a quarter. What do I see? Plus a quarter. So I'm taking, what am I doing? I'm taking this out here. And I simplify all those t's, gives me t squared. So now it's 0. Okay, because t is going to 0 plus. So my final answer is minus a quarter. Okay. So I did all this work and it ended up being 0. Unfortunately, you must do all the work. Otherwise, I will put a big question mark and subtract.